see your screen as well. So let's find out. Let me refresh YouTube. No, it hasn't started yet according to YouTube.
YouTube just says live stream is starting soon.
Started streaming less than a minute ago.
Oh, here we go, loading. So we can see your screen.
You might want to mute. What's it called? YouTube as well.
That's really confusing.
I'll just do one more thing. Alright, I think that's pretty good. I can't
Cool.
see it though. Cool. Alright. So let's go through these quiz questions. Hopefully it's all recorded.
It's on YouTube at the moment.
Yeah, I know. But let's see. See what happens. Well, it looks like it's recording. And it's moving around. There's a little bit of a delay. It's recording at 720p. I wonder if we can lower that.
Probably a good idea if you can.
It'd
be a good idea if you could.
Yeah. I'm not sure exactly how. But oh well. There's 4 people watching now. I'm guessing 2 of them are us.
Most likely.
What time is it? 20 past. Alright.
Yeah.
We should get started. I just want to quickly see if I can change the... If anyone's there, we're really sorry. We're just trying to set things up. I'll wait for the chat. Let's look at 5 viewers. This one, I can't seem to change it, I think.
I guess we can work that out later.
Yeah, there's someone kill my internet either. That's okay. All good. Alright, let's get started.
Alright.
Okay, so welcome to the PES Extra Help session. If you're here, just say hi in the chat. You should be able to access the live chat on the side. I've also put the Hangouts link in the chat on YouTube. So you should see a YouTube chat. I'll put it back up in there again, just in case. If you want to join in on the chat, you're welcome. And it's there. Alright, what's that? It's only me and you at the moment anyway. There's 5 viewers. Cool. Alright, so what we're going to do first is go through the quiz questions. So the first question we've got here is, which statement correctly declares an integer variable with the name num and initializes it with the value 10? All right, we've got 5 answers. They're all statements, so we need to look for which one has these 3 conditions: an integer variable, the name num, and initializes with the value 10. So let's start by looking for the keyword that's associated with the integer variable, and that is int. So int is for integers, float is for floating point numbers, set is not. Why'd you use set?
So set is just sort of a decoy, just to test people's understanding.
Yep, cool. And this one doesn't have a type, which we can't use. So we know already that it's going to be A or D. The second condition is that it has the name num. Now, in this question, we can see that they're all named num. So that's fine. And the last thing is initialize it with the value 10. So we create a variable. If we just create a variable, then it will have an unknown number in it. We've just created a space to store a variable. But if we want to actually set it to a value as soon as we create it, we need to initialize it. And we do that by giving it a value right from the start. So it can't be this one because we don't give it any value, but in this one we do. So we create the variable num, and then we initialize it to 10. So num becomes 10. Okay? All right. Let's go to the next question. Josh can explain this one. Can we go just next question? No.
So you have to close and open the next one?
Yeah. All right, Josh, you want to take that one away?
All right, so out of the following, which data type would I use if I want to store the value 3.5? So the first thing we should notice here, out of our responses, we see decimal, which we haven't seen as a data type because it's not one of the ones that we'll actually be using. So that's another one, another decoy in there. We have signed int, float, and char. So the first thing we should be looking at here is what we're trying to store. So straight away we know that 3.5 is a number. So right away we know that we can eliminate E, which is character. Next thing we should be able to realize is 3.5 is a decimal. So what we know about integers is integers can only store whole numbers. So straight away, even though we haven't seen this signed int before, we can still eliminate that as an option because we know that ints can't store decimals. And as of course we know, what we use to store decimals is we use a float. So in this case, we should find that D is the answer.
Cool. And if you wanted to test that, you could always print the answer as each type and see what happens.
Definitely.
So D is a float. Cool. Let's keep going. There's more programming type of questions later, isn't there?
There is, yeah.
Yeah, we'll go. We can create them programs.
And as another thing, when you're doing these quizzes, if you're ever not sure what these things are, you can always try and just write up a small program and compile it to see what happens.
Just be aware of time, though.
Definitely, yeah, 15 minutes, so have to be quick.
All right, so the next one. I think we lost someone. Are you still watching the stream?
No, but I can be.
No, it's all good. It was just that one of the people dropped. I thought it must have been you. All right, so now we have. I think we have someone else here as well. We have Nathaniel. Cool. I can't hear anyone else, but
either. There's 3 people watching, so I think we've only got 1 more.
We've got 3, but we've got 3 people in the Hangouts.
Isn't that the same thing?
No, in the Hangouts.
I don't know.
In what we're in. Someone's
Aren't they linked?
Josh.
Okay.
So
Carry on.
Okay, cool. All right. Which statement correctly declares a floating point variable with the name fnum and initializes it with the value 3.5? So in the first question, we had a similar problem, except for we were talking about an integer variable. Now we're looking at a floating point variable. So as I said before, int was for an integer variable. This one here doesn't have a type, so it can't be that one. So the allowable types are going to be int, float, double, short, char, and so on. This one doesn't have a type. We can't declare a variable without a type. However, this statement is okay as if we defined it earlier, but it's not. It doesn't answer this question because we're trying to declare. So all declarations must have a type. And the set was Josh trying to trick you. There's no command to set in C like this. So knowing this, we've eliminated int. We've eliminated this one because there is no type. And we've eliminated this one because set is just a trick. So once again, it's either of these two. They're all named fnum. Oh, the first one isn't. So that makes it even easier. These two are named fnum, but we also need to initialize it with a value. Now, saying that this is still a legal operation, you can do this, and you can do this. It just means if you do this, you don't know what the value is. So we initialize it to 3.5. So the answer here is C. If anything's going too quick or slow, or you want us to speed up, just type it in the chat. Either chat as well. All right, Josh, you want to take the next one?
Cool.
Number 4. I pressed the wrong button.
Yep.
There we go.
Awesome. Cool. So which statement declares 2 integer variables, num1 and num2? So again, the first thing we're going to be looking for is what type of variable we're trying to declare. So we can see that we're trying to declare 2 integer variables. So straight away we can see that A and C are the only options that might be what we're after. As B is, again, set integer, which was me trying to trick you, and D and E are for floats. So the next thing we're looking for is we want to declare 2 variables at the same time. So we can see for option A, num1 and num2 are separated by a comma, and for option C, num1 and num2 are separated by a space. So what we're looking for here is num1 at comma num2 will be our answer. This is because when we want to declare multiple variables in the one line, we need to separate them by a comma so that C knows what we're talking about. If we just use a space, C doesn't really know what we're getting at because there's nothing to separate the 2 variables there. So that's why if we ever want to declare more than one variable in the same line, we need to separate each of them by the comma.
Cool.
So in this case, A should be our answer.
Yep. Cool. All right. Number 5. All right. So this is another declaration question. Which statement correctly declares? Oh, I opened it. Oh no, that's right. Which statement correctly declares a character with the name temp and initializes it with the value f. Note the integer value of character A is 65. Alright, so this one's a little bit trickier, but let's start with the first part and just start eliminating stuff. So we're looking for a character. Now a character type can still hold a number, but it's designed to hold characters because they are a byte long. And we're using the ASCII code. If you want to look up on Google, it's ASCII. So, I'll actually get the table up, actually. That'd be a good idea. Alright, so we've got the table here. So, in this question, we want a character with the name temp initialized with the value f. You'll notice that the f is in single quotes. This denotes that it is a character, a printable character. So something that we can see on the screen as a letter. So once again, this set we can eliminate. We know set isn't a command here. So it's one of these four. Once again, this one doesn't have a type. So for declaration, this is invalid. We can see this one here does not initialize to anything. Now, we've got this one and this one. Now, when we look at this, we see both as 70, but we're looking for a character type variable. So we know it's this one, but how do we know it's 70? So the clue here is the integer value of a character A is 65. So what we can do is have a look at the ASCII table and see A is 65, and this is what it's referring to. So every letter has a value. So we look at letter U, it's value 85. If we look at letter J, it's value 74. So F is 70. We could also count it from 65. This is why the 65 is given, because A would be 65, B 66, 67, 68, 69, 70. So F is 70. So we can actually just use the integer value to initialize the variable. Now, we are declaring it as a character, so we use the char type. However, this will still work, and this will still work, but that's not what the question asks. This one is the answer. Okay? Be aware, however, int is larger than a character, so we still could hold the letter F in there if needed, but it is not the answer because it asks for a character. So the answer here is B. All right. Number 6.
Cool.
Right. Yep.
Yep, should be. Awesome. So we're looking at what is the storage size of a char in bytes in C. So Matt kind of talked about this just in the last question here about a character and how much it can actually store. So what we find is that each of our variable types have a different range of values that they can store, and that's based on how much space they use up in memory. So what we can see is we've got 1 byte, 2 byte, 3 bytes, 4 bytes, or all of these bytes are making me hungry. So straight away we know that B is not the answer. So we're left with 1, 2, 3, or 4. Now in this case, the answer for this one is 1 byte. So a byte is the same as 8 bits. And what this means is that when we, as Matt's drawing on the screen there, when we try and store something we actually store it. The 8 bits is a binary representation. So when we're trying to store the character, as what you saw with the character F beforehand, it had a representation of a number. Now we can represent that number in binary as well. And if we worked out what that was in binary, we'd actually see it stored something like what Matt's got on the screen there, when we want to store it in memory. What we find is when we have integers, these can store more than what a character can store. That's why you'll learn about this in the next few weeks, but each different data type can only store so much because it only has a certain amount of space for it in memory. And do you want to add anything to that, Matt, based on what you've got there on the screen?
I think that covers it. Is there any questions?
Yeah. And you'll also be learning more about binary and hexadecimal in the next few weeks as well, which will make this stuff make even more sense.
The only other thing is, yeah, so this is 8 bits. You can think of it as switches being turned on and off. So to store a value, we basically store each binary bit as an on-off state to create a number. So this is 0, 0, 1, 1, 1, 0, 0, 1. And similar to decimal, we have the first digit's the ones, the second's the tens, next is the 20s. In binary, the first is the ones, then 2s, then 4s, then 8s, then 16s, then 32s. So if we add all this up, this value right here is actually 57. Oh, you will go to this later, but the character is 8 bits wide, which is 1 byte. So 1 byte equals 8 bits. So if we had, let's say, an int which is 4 bytes, then we have 32 bits.
Cool.
All right. Number 7? Oh, there's no number 7.
Back to number 1.
Back to number 1. Okay. So this one concerns printing, and a lot of this you did in your first lab. So hopefully this isn't too difficult. And we can simulate this one as well. So what we see is a printf statement. Sorry. We've got a statement with a printf function, and we've got 3 arguments here. One argument here, separated by a comma, then a 10, a comma, then 2.537 in the last argument, 10 in the first, and text in the first one, 10 in the second, 2.534 in the third. So for functions, for any function, it's the function name, and then everything in brackets is the arguments. And so for this case, we have 3 arguments. All the arguments are separated by these. Cool. So this first argument defines what we want to go out onto the screen. Is that you, Josh?
What's that?
That's vibrating.
I think so.
Phone? Cool.
My phone, yeah.
All good. So this first one is the text that's actually going to go out to the screen. Now, it's not exactly how to look on the screen, because we want to be able to print stuff to the screen based on some calculations or the user's input or some other commands that aren't just text. So in this case, the first one that stands out is the /n. We don't actually see the /n on the screen. All that means is new line. So it means that once this text is done, the cursor goes to the next line and whenever it starts printing again, it will start printing. If you forget to do this, then when you do another printf, it'll continue on from the last time. So, for example, if we had printf A, and then we had printf B, on the console, we'd see AB because there was no new line. However, if instead we did printf A/n and then printf B, we would see AB. That's what the new line is for. So you won't actually see this, you just see that it goes to a new line. So that's the first one. The second one is these percentages. The percentages have some options. So this is these numbers. And then a type. So these are called format specifiers, and these describe the format that you want your output to be. They will accept any type, and they will try to print it, but not every type will look right printed in certain formats. For example, we can print an int in a floating point format, or we could print an int in a character format. But if we tried to print a floating point number as a integer format, it's not going to look right. All right, so this first one here is, let's ignore the number first, is D, which is decimal integer. So a decimal integer is an integer without any floating point numbers. So it can be things like 2, 3, 678, 12, etc. And it cannot have things like 6.7. That can't be printed. So if we want to print 6.7, we have to use the F, which is the floating point format specifier. Okay, so this is the integer format specifier, and it's the decimal integer. You can print integers as different number systems, so you could print a octal integer or a binary integer, etc. We'll get to that in later labs. Let's have a look at the numbers. So I'll actually get the format specifier standard up. A sec. Okay. So if you search up format specifiers, you'll see that there is these flags, and this is in your lectures as well, but this is a little bit more complete. So we've got left justify, always display a sign, so it'll show the plus or minus sign for a number. Space displays a space if there's no sign. You can pad your number with leading zeros, so if you wanted something like 0, 0, 10, you can do that. And you can also use alternative forms. Now, the first value here is the width specifier. So basically it says that the smallest space you should use is 4. So, for example, where's my paint? So here we want to print value, and we want it to be at least 4 long. So what it's going to do is, let's say our value is 6, it's going to print 6 and leave some spaces. 3, so that at minimum it is of size 4. If it was 5, then it'd be 4 spaces, and then a 6. So that would be %5D. Now, with this, if our number is larger than the width, it will just be larger because this is the minimum width. So if I put, let's say, %2D, and my number was, say, 9999, then it's still going to print the 999. It is larger than the minimum width, which is 2. So if I tried this same thing with 9, because it needs to be of width 2, it'd be a space and then a 9. Okay? So what we see here, now this format specifier refers to the first argument. The first format specifier refers to the first argument after the text. So the first argument after the text is 10. So we know that this is going to print a 10 as a decimal integer. So 10 in decimal is 10, and we want it of width 4. So we look here, and we can see that these two have these spaces here, and there's 2 spaces. So we can see in total, this is of width 4, and it is printing 10. Here, it is printing 10, and it is width 4, but it's negative. Our value isn't negative, it's positive, so we can rule that out. We can use format specifiers to left justify. So you can use the negative symbol, so negative 4D would left justify it, which is this one. So if I put negative here, negative 4D, we would have got this, and that would have left justified our value, but we didn't do that. Here, it is a minimum width 4, but our number's 10, not 1,000, so that can't be the answer. So we know that our answer has to be one of these two, because the width is of 4 and our value is 10. So that's fine. Now we look at the second one. So we've got a floating point format specifier, and we see this 0.2. So we can look up here, and we can see that using a float, the dot specifies how many digits after the decimal point. So for us, we want 2 floating point digits after the decimal point. So for example, if I was to put in %.3f, and my value was 56.78888, then it will print 56.788. All right. So, knowing this, we see that it's 0.2, so it's going to print 2 decimal points, and our value is 2.534. Now also be aware it does print the zeros. If you specify the 0.2, it will always print the number of decimal places. So the first one has 1 digit after the decimal point, so it can't be that one. Oops. And we can see this one has 2 digits after the decimal point. this format specifier came second, so it refers to the second argument after the text, the third argument. And so our answer is this value. All right, anything you want to add, Josh?
No, that sounds pretty good. The only thing I'll say is just in your example before with the 78.8888.
Oh, did I not round?
I believe it rounds, so that'll round up to 78.889. Yep. Yeah. So yeah, when you use the decimal place specifier, it does round for the decimals.
0.3 F, my mistake. 6.7888 will actually become 6.789.
Cool.
All right. Which one are we up to?
Number 2, F2.
Looks like the same.
All right. So this is a very similar question. We can see the only thing that looks like it's changed is instead of being percentage 4D, it's now percentage negative 4D. So this is essentially going to be the same as what Matt has just explained, with the only difference with that negative sign. So what we saw before in the last question, when it was just the percentage 4, that meant that it was right aligned. But in this case here, because it has a negative sign, that actually means that it's left aligned in this case. So looking at the answers we have, we know from what Matt was talking about before, straight away we can eliminate C and D because those have actually changed the number 10. So in C it's actually changed it to negative 10, and in D it's changed it to 1,000. So we know that those can't be the right answers. Next up, if we look at answer E, we can see this looks pretty similar to the last question, but remember this time we want it to be left aligned, the number 10, not right aligned. So we know that we can eliminate E as our answer this time. So straight away we're left with A or B. We can see the only differences in these answers is the 2.5 or the 2.53. So what we'll have to do is we have to look at the printf up the top there and see it says %.2f. So this means we're printing to 2 decimal places. So we can see the number was 2.534. So to 2 decimal places, we should be looking for 2.53 as our answer. And we can see that there that looks like answer B.
Ta-da!
Yay!
All right, let's go to the next one. So we're up to 3.
F3, yep.
Cool. All right. Oh, Josh has just written the same question over and over again.
Oh, this one's a bit different again.
All right. So this is similar to 2 questions ago. We've got the same in the text. We've got the same as the first question that we showed in this of these type of questions. So %4D, we're looking for a decimal integer with the value 10 and a width of 4. So we can eliminate this one, we can eliminate this one, and we can eliminate this one. This one's left aligned, this one's the wrong value, and this one's the wrong value. So once again, we're left with this one and this one. So A and D. In the second half of the text, we see this has changed. And we've now got 0.1f. So this means that there's 1 decimal place now. So given this value, 1 decimal place will be 2.5. D can't be the right answer because it has 2 decimal places. Here it has 1. So the answer is A. Cool. All right, number 4.
Cool. All right, so we've got a different question this time, which is good. So what format specifier would you use if you wanted to print out a single character. So options to choose from are %F, %D, %C, %S, and %X. So straight away, from what we've done so far, we should be familiar with the top 3 responses there. So we've seen that %D is to print out integers, %F is to print out floats, and %C we know is to print out characters. So in this case, we will be after %C. Just to go through those last 2 options we have there, though, we will probably see these in the coming weeks in the course. %S is what we'll be using if we want to print out a string of characters. So what that means is, instead of just printing out a single one, it's like we've just got a bunch and we put them together and printing out the whole string. And the last option there, %X, is to actually print out a hexadecimal representation, so the hexadecimal value. So we may be using this when we go through different numbers, so when we're doing hexadecimal and binary a bit later on in the course. But for now, all we just need to know is that it's there, but we won't really be using it for the time being. So yeah, so in this case, we find that %C should be our answer to print out a single character.
Yep. Once again, if you want to know any of the format specifiers, they're quite easy to find. They're all on Google. This is all the standards for ANSI C. So these are all the possibilities that you can choose from. All right. All right, so similar to Josh's question before, we have, that was me. I'm moving my phone. All right, similar to Josh's question before, we have a set of format specifiers, and we want to print out a float variable. So this one's eliminated because it's a string. A floating variable is not going to print out as a string. It's got floating point digits, so it's not going to point out as a decimal integer. It can't print out as a character. All the characters are integers. Even the ASCII characters are integers, so you can't print out a floating point ASCII character. The table I showed you earlier, the ASCII table, as you can see, come on, I won't leave that up. They're all integers, so it goes 64, 65. There is no character with 64.5. So it can't be that. Josh just showed you, this is for hexadecimal numbers. And then the last one, we've got the floating point format specifier. So this is the only one that can print out a float variable correctly. Be aware though, you will get warnings if you try and use these, but you won't actually get an error when you compile. You get warnings, and your output will look wrong. So make sure you choose the right one for your output. All right. Hey, we've got another person. We've got Antonio in the stream, I think.
Cool.
He's hacked our stream.
He's in.
He's in. All right.
I'm in like Flynn.
You're really loud. Let me make him quieter. I've forgotten how to do that. Ah, there it is. Found it. I'm going to make him a little bit quieter. Talk, Antonio.
No one wants to listen to me.
Yeah, that's why we're making it quieter. We were going to meet you, but...
I'll mute myself.
No, I'm joking. You don't have to. How's it going?
Good. How are you?
Yeah, pretty well. Josh, what were we up to?
So we're up to 6, F6.
F6. Kill. Oh, wrong button.
Right there.
F6. Cool.
Awesome. So in the following C code fragment, what does the .3 achieve? So we've got printf. My average score was %.3f with an 87.2344. So as we've discussed before, we should all know what the .3 does now. So straight away we can see, in this case, prints the number to 3 decimal places. Sounds pretty good. Going through the other options there, prints the number with a width of 3. We've seen in the past that to do this, we don't use the full stop. We're just been using a number to do that. So because of that dot there, we know that B won't be the answer. C, this is not a valid C statement. It is a valid C statement, so it's not going to be that one. Multiplies the number by 3 before printing it. We can tell that it won't do this because it's only formatting the text. It's not actually doing any maths on the numbers that we're printing out. And the same logic for that for E. So moves the decimal point to the right by 3. Again, we're only formatting what we're printing out. We're not actually multiplying or doing any maths to that number that we're printing out. So in this case here, we should find the answer will be A.
Ta-da!
Yay!
Where are we? Okay. I think this is the last of this set. Alright, so once again a very similar question as before. So we can go through this pretty quickly. Now, this one's a little bit more interesting because we want to print out a double. So with our format specifiers we saw before, we want to print out a double. It can't be a hexadecimal number, can't be a string, can't be a character, and it can't be a decimal integer. However, it's not a floating point number now, it's a double precision floating point number. And so we used the format specifier long float, which is this one. That one's a little different than the normal float because we need double precision. Anything you want to add?
Well, I think that covers it. Yeah.
Cool.
Easy.
I'll just close it. All right, we're on to the next section. How many sections have we got?
Cool. I think there were 4 sections in this.
Yep.
Yeah.
So this is the coding.
4 or 5 actually. 5.
All right.
Alright, so what is the output of the following C program? Cool, so we've got a fair bit going on here. So oftentimes the best way to do these questions is we can keep track of every variable as we go through sequentially. Because as we know, when we're executing our code, we execute the code sequentially. So from the first line right to the bottom. So starting with our first line there, so of course we've got our include up the top and our int main. The first line that gets interesting is int a equals 3, comma, b equals 2, comma, c equals 3. So again, what we were talking about before, if you want to declare more than one variable on the one line, you have to separate them by that comma. Otherwise, if you just use a space, like what we saw earlier, C won't really know what you're talking about. Cool, so at this stage what we can see is that A is equal to 3, B is equal to 2, and C is equal to 3. On the next line, we're seeing B equals A minus 1. So what we're doing is we've got our variable B that used to have a value of 2, but what we're doing is we're actually changing what that value is. So the way that we work this out is we see that at this stage, on the right-hand side, so B equals A minus 1, at this stage, A is equal to 3. So what we kind of do is we grab that value 3 and we plug it into where we see A. So right now what we should be seeing is b equals 3 minus 1, which in this case we can see is 2. So at this stage, b was equal to 2 before we did this, this line of code. It just turns out by coincidence that it's the same afterwards. Now on the next line we've got a equals 4. So straight away this is an easy one. All we're doing is we're just overriding the value of a, which was 3, and now it's going to be equal to 4. Cool, so next line we've got here, c equals b multiplied by a. So again, we have to look at what value we had for b. So last we checked, b was equal to 2. And last we checked, a was equal to 4. So 2 times 4 will be 8, and that will be the next value that's stored in variable c. Now on the final line there, before I return 0, we're printing out the string of characters, so the result is, and then we're printing out an integer. Now what we can see in this case is it's a bit interesting than what we've seen before. In the past we've just put a single variable after we use that comma for where we want to put our variable that we want to print. But in this case we've actually got c plus b. And this is allowed. So what C is doing is it's looking to whatever variable or whatever value is stored in that C plus B. And because we're actually doing some maths there, so C can handle that. And what's going to happen is it's going to work out what C plus B is, and then it's going to put that value in place of that percentage D. So looking at what we have so far, the last that we said was C was equal to 8 and B was equal to 2. So we should see that the result of that is 10. And so we're going to use that 10 and we're going to replace it for the percentage D. So what's actually printed should be the words the result is, colon, and then followed by the number 10. So looking at our answers there, we can see that it's actually E. Now in this question, it is very easy to slip up and forget that we're actually printing out the words the result is. So there have been a lot of people who forget that we're actually printing out the string of characters as well, and they've done all the hard work, they've worked out what the variables are, and they've just said what that C plus B is, which is 10. But we've got to make sure that we're printing out that whole string of characters, so the result is colon 10. So we've got to make sure we put that in our answer there. And yeah, do you have anything you wanted to add to that, Matt? Or
Nope.
yeah, awesome.
Sure.
So yeah.
All right, so that was that one. Okay. Okay, so this time, just be aware. The first thing that you will see here, this isn't a full program, it's just a fragment. So when you see that, imagine that the includes and the mains and all that is there. We're just looking at a fragment of the code. So just these 2 lines. All right. So we create our variable f. So we can imagine that as a storage space, and we give it the name f. It's of type float, so it can hold floating point numbers, and we initialize it to 2.5. So we put 2.5 into it. We then, as before, we use the printf statement, and the format specifier here is a floating point format specifier, once again with 1 decimal place because of the 0.1. So we look at our argument that follows, and it's f, so we take the value 2.5 and we print it to 1 decimal place. So we can see that a is our value, and it's 2.5. Once again, Josh, stop making so much noise.
Sorry.
We can see this new line character. You won't see that in the answers. because we haven't got a multi-lined output. But we did go through that before. Now, if we want to print a percent, it's actually harder than just typing percent. We actually need to use a /%. So we know this isn't the right answer. F by itself is not the right answer because we're printing this text out. So all this gets replaced by our answer, and this gets replaced by a new line. We know that there'll be an output because we're using a printing statement to the output, and we also know that there's no other extra F here, so it won't be this one. So we know that the answer will be A. Clear?
Awesome.
All right.
Cool. So this one here again is similar to the last one that we did together. So what we'll see from the start is in this case here, our A variable starts at 1, our B variable starts at 2, and our C variable starts at 3. And just again, notice how we've declared multiple variables on the same line. So to do that, we have to separate those by the comma. So first thing that's happening here is we're saying B equals A plus 3. So we're going to grab what A is equal to at this stage, which is 1, and replace that in that line there. So what that effectively becomes is B equals 1 plus 3, which is just 4. So what we do is we overwrite the value that's stored in B, which was a 2, and now that's going to become a 4. Next line that we see there, A equals 0, that's a nice easy one. We just overwrite what's in A and we replace that with a 0. And the next line there for C is C equals B multiplied by A. Now at this stage, B is equal to 4 and A is equal to 0. So we know the result of this is simply going to be 0. And so with that as well, we can overwrite the value that's stored in C, which was a 3, and now it becomes a 0. So finally we're printing out the result is, and then we're going to printing out an integer. So we look to after the comma in that printf, and we see it's C plus B. So at this stage, as we can see, we've got C is equal to 0, B is equal to 4. So the text that we're going to be printing out should be the result is 4. And as we can see there, that looks like option B.
Cool.
Yeah, easy as that.
Ooh. Have you got the stream open on Facebook? I mean,
On
YouTube.
YouTube?
Sorry?
Yeah.
Okay, just checking the numbers.
4.
Cool.
Might be worth keeping P3 because that's this. Or no, P3 is a bit different. Never mind. Carry on.
Okay. Yeah, well, actually, it's a good one because they don't initialize.
Yeah, sounds good.
All right. So similar before, we see ourselves declaring 3 variables. We have A equals 4, so we can initialize A to 4. However, B and C aren't initialized. They will have a value, but it is unknown to us at this stage. So we'll just represent it as a question mark for now. If you print this, you'll get unknown results. So this is why it's a good practice to initialize your variables when you can. We now have B becomes A divided by 2. A is 4. 4 divided by 2 is 2. So now B has a value that is known. So we give it a value. We then say A becomes 2. So we change A to 2 by overriding it. And then we have C becomes B plus A. So B plus A is 2 plus 2, and we get 4. Goodbye question mark. And similar to before, we print out some text, so we know that B or D is our answer. And then we have our format specifier, which refers to, it's the first format specifier, so it's the first argument after the text, and it's going to print out C. So we grab our C variable, and it should be 4, so the answer is B. Anything else?
All good?
No. Cool. All right. This one? Ah, yes, this was a good one.
Number 4?
Yes.
Cool.
All right. Let me just delete these.
Awesome. So we've got another one here, and this one looks like it might have a bit of a twist to it. So what is the output of the following C program? So again, we've got our include up the top and our int main. So first interesting thing that's happening is we're initializing A, variable A, which is an integer, to a value of 7. Variable B, which is again an integer, to a value of 2. And variable C, which is not initialized, so we know it's an integer, but we don't know what value it stores. So on the next line here, we're saying C equals A divided by B. So what we can see at this stage is A is equal to 7 and B is equal to 2. So just by first glance looking at this, we think the value of this is probably going to be about 3.5. I think that's right. Yes. So just by looking at it, we sort of think it might be 3.5. But there's something that we've got to realize before we get to that answer. So as we said before, all of these variables are integer types. So what that means is integers can only store whole numbers. When we're doing this division of A divided by B, we don't only have to look at the numbers or that we're dividing by, we have to look at the data types too. So we said that A was an integer and B was an integer. So what that means is C will think that an integer divided by an integer should give you a result as an integer. And the reason it does this is it just tries to make your life easier and predict what you're thinking. So what we know about integers is they only store whole numbers, and we predicted before that the result of this division was going to be 3.5. But we know that 3.5 isn't a whole number. So what happens is C just chops off everything after that decimal point to give us an answer of 3. And the reason it does that again is because the answer to this division is 3.5. C says, well, I don't want to make that a decimal because the answer should be an integer. So what's going to happen is everything after that decimal point, I'm just going to ignore. This happens as well if we had something that gave us an answer of 3.99999. Again, because the answer is an integer, C just forgets the decimal point, and the answer will still be 3 in this case. So this is something really important to watch out for, and you would have all seen this happening in the labs as well this week. So if you ever get zeros as your answer, that happens sometimes. The reason probably happens because you're dividing an integer by an integer, and it's forgetting that decimal point. Awesome. So at this stage, the value that's going to be stored in C will be 3. The next thing we see happening is we're printing out the result is, and then we're printing out an integer, and the value that's going to be placed in there is C divided by B. So again, looking at what's stored in C and looking at what's stored in B, C has a value of 3, B has a value of 2. So 3 divided by 2 is about 1.5, but again, following the same reasoning, we're dividing an integer by another integer, so the answer to this is going to be an integer. So again, 1.5, we're going to chop off the decimal place, and we're going to be left with 1. So the answer to this question should be the result is 1, which looks like A. you have anything else you wanted to add for this one here?
Nope.
No. Awesome. So yeah, sounds good.
Sounds good.
Cool. And this is something really important to watch out for in your labs because it does get a lot of people. So when the answer isn't what you think it is, it's often because of an integer divided by an integer.
Hey Josh.
Yeah.
You did the same question twice.
So I did. My mistake.
Lucky people who got that question twice.
Whoopsies.
Yeah. I was just helping everybody out, that's what it was.
GG, Josh. GG.
That could have been good for some people, or bad for others.
I think I came across
If you got
that
wrong.
question twice. I just never
Pardon?
said anything.
Yeah.
I think I came across that question twice. I just never said anything.
In the
It
same
never
quiz?
occurred to me. One of the two.
All right. You might want to take a note of that, Josh.
Yeah, I'll just delete one.
Actually, I can do it right now.
Oh, I just did it, don't do it.
Oh, okay. All right. So the next one. Oh, our famous Hello World.
I can't delete
Alright.
it. Sorry. Never mind.
Why not? Oh, because the quiz
Some-
is.
Some
Yeah.
people have already answered that question, yeah. But it doesn't matter, it's alright.
That's okay. All right. So our famous Hello World. We did Hello World in Lab 0. In Lab 0, however, we wrote. Where did my paint go? We wrote something like this. However, here we've got it on 2 lines. Now, this is a really good demonstration of why this /n is important. So the /n means go to the next line. As we saw earlier, we talked about this briefly, and we saw that printf, wrong color. We saw that printf, if I can spell, A, and then printf B would print as AB, whereas, oops, probably don't need to delete all that, /n here would go to the next line. So similar here, we've got hello world exclamation mark new line. Now, there's no text that follows, so in the answers we won't see anything onto the next line here. However, this hello prints, and there is nothing saying to the console to go to the next line. So we know that A isn't the right answer because it's going down 2 lines. We know it is an E because we've got no new line here. We know that it isn't B because we're using the printf statement and we're printing text, so that we know that there will be some kind of output. So it has to be C or D. Now, in our first program, we did include a space here. And so the space character was printed. Here, however, you will notice that there is no space between hello and world, even though they're separate lines of code. A space isn't inserted there, and so C is the answer. All right? Cool. I think we can rush through these ones because these ones are quite easy.
Yeah, they're all pretty similar.
So I'll just go through these ones. So the difference between this one and the last one, we do have this /n here. And so what we should see is that the hello, then another line, then the world. And hence, it should be A. We then have this one. Now this one, the answer's kind of been given by the note, and we see a space here, and so C is the answer. All right. So we are up to that one. This one's very easy.
Cool. Is this me or you?
Now you can do it.
Okay. So this one should be pretty easy after all we've been through. So we've got int a is 5, and all we're doing is we're printing out percentage d means it's an integer. So we look to the value that we're trying to print out, and we see it's a plus 1. So what we'll be doing is we'll be looking at what's stored in a at the moment, which is 5, and we'll be adding 1 to it. So that'll give us an answer of 6. And then we'll be grabbing that 6 and replacing it for the percentage d. Again, you can see the new line is there, but that won't show up in our answer. So the correct answer for this one should be C, which is 6.
Cool. All right. I was texting. Okay. So this is a new section. Yep. Cool. Okay, so this was one of the questions that a lot of people got stuck on in the lab, and one that you were asked to have a look at the values and see what they meant. So, at the moment, we create an int variable, a. Let's just slide that across a bit. We create an int variable a, and we initialize it to the value 7. We then create an int variable b, and we initialize it to 2. We then create another variable, but this time it's not an int, it's a floating point type. We initialize it to a divided by b. Now, in terms of the operations, we learnt before that an int divided by an int is an int. Now, when we've got float equals int, the order of operations is this happens first, then it becomes a float to be assigned to this float. So this value, when it's calculated here, will still be an int. So when we see C equals A over B, we will see our equation be 7 over 2, which in floating point math would be 3.5. However, because these two are ints and this operation happens first, the answer will be 3. So we've got C equals 3. Now, when this assignment happens with the equals operator, this will become 3.0 and be stored as a float. So our answer is printed as a floating point number with 2 decimal places as shown here, and we're printing C. So we know that there is some kind of output, so that's not the answer. We know that the answer isn't 3.5 or 3.50. So we've got to choose between A and C, and we specify that there's 2 decimal places. Now, even though there isn't any digits other than zeros in the floating part, we can see that this still has the 2 decimal places, and so our answer is A. Anything you want to add, Josh?
No, I think you've covered it all pretty well.
Cool. I've lost.
T2, I think.
Yep.
All right, so we've got a similar question here again. So, what's that? Cool. So straight away, first off, we've got int a equals 7. Then on our next line, we're seeing float c equals a divided by 2.0. Now, this question is a little bit different to the last one, whilst it might seem similar. But what we're actually having happening is we can see that a is an integer in our division. But when we have 2.0, this actually counts as a float. The reason is we're actually explicitly saying when we do the 0.0 that this number has decimal places. So we're actually dividing an integer here by a float. And what C does is what it was doing before when we had an integer divided by an integer, it thought that the result should be an integer. Now we're doing an integer divided by a float. C is smart enough to try and guess what you're after. And the answer to this is going to be a float. So this is because C is just trying to make your life easier and predict what you're wanting to do from the division. So when we do 7 divided by 2.0, the result will be a float. So it will actually be 3.5 as we expect it to be. So the value from this line is going to be 3.5, and that's going to be stored in the float C. So on the next line after this, we've got a printf statement, and we've seen plenty of these so far. So we're printing out the variable C, and we're going to be printing it to 2 decimal places. So we said that the C was holding the value 3.5, but we know this should be printed out to 2 decimal places, so we know that D isn't the answer we're looking for. So the answer we're looking for should be B, which is 3.50.
Cute.
Awesome.
You can fill in. I just realized that.
What's that?
You can press the button to select the correct one.
Oh.
Okay, so you just did the floating point literal. All right, typecasting. Cool. All right. So now we've got another similar problem. So once again, A equals 7. However, this time, let me delete B. Go away, B. We're declaring C, and we're initializing it to float A divided by float 4. So we've got C equals float A divided by float 4. Now, in terms of order of operations, the float always has precedence over the division. So you can imagine this as there is implied braces here, if that makes it simpler for you to understand. Especially when you aren't programming and you're solving the quizzes, you can put braces in, brackets in, to help you solve it. So the first thing that happens is A is going to be evaluated, then the 4, then the division, and then the assignment. All right, so we've got A is 7, so let's go through it step by step. 7 divided by float 4. We then convert the 7 and 4 to floats. I'll do it in one just to make it quicker. So we'll show that by giving, we'll represent this as 7.0 to show that it's a floating point number, and we'll show that the 4 is a floating point number. Now, the division will always take the highest type, and float is a higher type than an int, and so the answer will be the division of 7.4 as a floating point number. They're both floats, so the answer will be a float. And the answer is 1.75. Yeah.
Nice.
So we don't have the text here that says the output is. So we don't need to look for some text. We just have our format specifier. So the answer is just going to be a number. We're able to calculate the answer. So the output is certain, and hence we can also see that it's meant to be 2 decimal places, and hence our answer is 1.75. Cool. Is that all good?
Yep. That sounds good.
Close preview. Ah, blah blah. That's done.
The one above that, E1.
Oh, yep. Sorry.
Alright, so in this question we've got which of the following is a legal identifier? Now, what we mean when we say legal identifier, when we say identifier, we're talking about a variable name. So a way that we can identify, you could say, the variable or the value that's stored in the variable. And what we mean by a legal identifier is we do have some limitations in what we can actually call our variables. And we'll see some of those as we go through all of the different responses. So first off, we'll start with response A, second underscore num. Now, when we're naming our variables, we can only have letters, numbers, and underscores in the variable name. So that's one key thing we have to look for. Now, so far, option A, that satisfies all of those. We have letters, we have an underscore, and we have the number 2. However, in this case here, this variable name starts with a number. Now, this is not allowed. So this is another restriction we have. We can't actually start our variables with a number. And this is also, to get into good practice with our variables like we've been doing in the labs, we should never be starting our variables with numbers in the first place. Our variables should be ways that we can easily understand what that variable represents. Looking at option B, we have total, and then we have the $sign. So again, in this case, based on that first restriction that we said, the $sign isn't a letter, a number, or an underscore. So this one isn't okay because we've got that $sign in there. Now, looking at option C, we've got long. Now, this satisfies, only has letters, doesn't start with a number, and doesn't have any $signs. But this word here is actually a keyword. So we've seen long as a way that we can declare our variables in their data types. So because we're actually using this word long, and it means something else to C, we're not allowed to use it. It'd kind of be the same as if we were trying to make a variable, an integer variable, and give it a name of int. It just wouldn't make sense to see. So that's why we're not allowed to do that. These words have been reserved. Now, next up on the list for D, third space number. Now, in this case here, we've got 2 words here. So when C sees third space number, it thinks that these are 2 different things. It doesn't think that it's the same variable name. So another constraint that we have is we can't actually have spaces in our variable names, simply because C doesn't know what to do with it. As we saw earlier in this stream, one of the ways that we might have declared multiple variables on the same line was with num1 space num2 or num1 comma num2.
Josh, you just went
Now
a bit
this
robot.
is, I did. Hey, robot.
You just went a bit robot.
Robot, cool.
Repeat that. You better now.
Better now? Awesome. So again, this is why C just doesn't know what we're trying to get at when we have spaces in our variable names. So it can try to think about what to do, but it just has no idea. So this is why another restriction is we can't have spaces in our variable names. Now, by the process of elimination, E has to be the right answer. But just having a look at it, we see we've got an underscore, that's okay. And we see we've got letters. That's perfectly fine. It doesn't start with a number, starts with an underscore, which is okay. It's not a keyword, so it doesn't say long, doesn't say int, doesn't say float, and there's no spaces. So for this one here, E should be our answer.
Cool.
And did you want to add? Yeah.
I just wanted to add one other thing. With Unix, I saw a lot of people in the first lab trying to call their file names with spaces. You can't do that either, okay? So with your file names, don't put spaces. You can do some of the other things, and the file names do have different rules, but spaces you can't do with the file names because you won't be able to execute your programs. All right, Mr. Millward. Okay. Which of the following is a statement? Okay. Sorry. So what we're looking for here is a C statement. So basically, a statement is something that executes in the program. We can see already that C is a whole program. It is not one single execution of something. So C can be eliminated. We can also see here, B is a comment. So at the top of your code in the lab this week, we we wrote a description of our code, and that was the comment. Now the comments don't execute. So the first one is a macro to include a particular header file, and that is done during compile stage, and hence it does not execute while your program is running. It can't be A either. So the only statement here is B, because this is executed during runtime, and it is a single statement or line of code. Okay? Anything you want to add, Josh?
Oh, I think that's pretty good. Yep.
Cool. You can fill it.
Awesome. Cool. So for this one here, we've got similar answers to what the last question was, which Matt explained all of them. So which code sample below is an example of a comment? So straight away that we know that the answer is going to be B, because we can see it has the slash and the asterisk, followed by the asterisk and the slash at the end. Now there is another way we can do comments in our code. So doing with the slash and the asterisk is for a multi-line comment. What this means is all the code after the first slash and the asterisk will be commented out until we see the asterisk slash at the end. Now this is different to a normal comment or a single line comment, where instead we just use the double slash, and then everything after that double slash only on that line is commented out. So that's another type of comment you'll see that you can use in your code. But yeah, so in this case the answer will be B.
Cool. And lucky last, I think. A comment. Okay, so we looked at before, and we talked about stuff that happens during the pre-processing stage. So this is before while your program is being compiled and being created. There are some things that can be defined. You can use different statements to, well, not statements, basically directives to choose different things to define or choose which parts of code to execute. And this all happens in the pre-processing stage. So the hash include standard IO library is a directive. It happens in the pre-processing. So B would be the answer here. And that's the last of the quiz questions. So, woohoo! Has anyone got any questions?
I do.
What's your question?
I don't know if you got my email before. In regards to compiling with the math library.
Yeah.
Do they need to be linked?
Yes. Well,
Okay.
it's a, yes.
Well, when you compile, do you have to explicitly say
minus
link?
LM. Yes.
Yeah.
Yeah. No. We actually fixed that up earlier today.
Oh, did you? Okay. Because
Yeah.
I'm like, that's probably something that's important in the lab sheet.
Yeah.
Yeah.
Yeah, it's in the lab sheet now.
Ah, cool. That's all right. I figured it out in the end. I'm like, it works.
Unless you're using an ID that's got it already set.
Well, as I said, I'm pretty sure I said it. I use Sublime Text, which when I compile using Sublime Text,
Yep.
it does the linking for you. So.
I'll just check my emails. When did you send it?
Oh, a couple of days ago. Let's unless it didn't send.
I think I got a couple of emails about the thing. I think I read something. I remember. I think it was you.
It would have came through my Gmail because sometimes when I send emails, I don't look up where I'm sending it from.
I remember someone said something about linkage. It was probably you.
Yeah.
Did you have a question?
About this?
I thought I would have responded.
No, I did. I did send an email.
I probably just ignored it. Oh, good.
But I ended up figuring out the problem in the end, so everything's working. And I did the challenge quest.
I think it was more that you already had the answer in the email.
Yeah.
I just
like the answer's right there.
You answered your own question.
Idiot.
The challenge question for this week? Or last week?
I've done both.
For this week?
Yeah.
Okay. We don't want to talk about that yet.
No, I know that.
Okay.
But this week I've already done it, yeah.
Well, we can give away the answer. So, what was your answer?
Hang on a second, let me pull it up. Well, what I did was because the printf statement returns an integer. Oh, sorry, not the printf statement. The printf function returns an integer.
Yep.
And it'll actually return the actual size of what is actually printed to the screen. So, like if you had a number, say like 1, 2, 3, it would actually return 3. And if it was a negative, say like a negative 1, 2, 3, it would actually be 4. So however many is actually. Sorry?
It doesn't return the size, it returns the number of characters printed.
Yeah, not well. I'm saying how it works in my head.
Yeah, just because size means there would be 4 for each one if it was an int.
Yeah, 4 bytes.
Yeah.
Yeah, something like that. Where am I going?
Because there is
PES.
functions that do actually do that. They return the
number,
the size.
Yeah. Which
so
is. Sorry?
So you got printf.
So just hang on a sec. Where are we? Here we are. Challenge. Open with. Oh, don't give me the shits. Fine, let's use Xcode. Okay. So what I did is actually printf. Then inside the quotation marks, you got a space %d \n. Yep. And then as the parameter passed in for the that formatter specification, that's format specifier, you go printf, and then in quotation marks %d, and then the variable that I'm assigning for what I've actually taken in from the keyboard. So in this case, I just used A because it was just simple. It was a simple problem to solve, which I admit the guy that I sit with, I talked to him about it. I'm like, he kind of gave me the hint what it was, and I'm like, he goes, look at the function. I'm like, all right, I look at the function. I looked at it. As soon as I saw it, it said it returns an integer. So that kind of sealed the deal in that case. So it kind of helped, but also figured it out myself in the end.
All right. So for everyone else's knowledge, anyone else wants to know, basically how it works is when you've got a printf statement, whatever happens here will execute first.
Correct.
Because it needs to calculate this to print it here. So earlier we saw in the quiz questions, we had A plus B here or something like that. And so this will get calculated first, or executed first. So this printf actually happens first. And all we're doing is printing the number. So printf the number. So at this stage, we've just printed our number out, whatever the user entered. Now, this printf statement actually returns a value, meaning that the printf will give back a value, which we can imagine will be here, and can be used for this format specifier. So let's say we had 325, then it will return 3 because that's the number of characters. So we can see that as being something like, oh, whoops, wrong button. So that as being a 3, and then we know the 3 printed as decimal will just be 3. We've got the space here. So we've printed out a digit with space, and then we print out the 3, and then we go to the next line. And done. Some people didn't include this new line, which they were so close, and they kept confusing themselves because they'd see the line number in the console.
Yep.
So just a really good point for any program you do, always put a /n at the end, or else your code will basically end with the next line on the console.
And you're like, oh, it works. It works. Hang, it's not 105.
Exactly.
What actually tricked me up was the getting the space between the numbers that you printed out. When you explained before, it works out the argument that you've passed in for the first printf for the outside one. So the printf that you passed in as an argument for the format specifier in the first one. Go space %d. I was trying to figure out where the hell do I put the space. So I was putting the space behind the D, and I'm like, it's supposed to be there. And this is like, kind of got help for that one.
Yeah, it's a good question to see where everything fits and which order of execution.
Oh yeah, it makes you think.
Cool. Josh, are you still alive?
Yeah, I'm still here. Still breathing.
We've been up for an hour and 40 minutes. So
yeah, something about that.
You're gonna get some pay. You're gonna get some overtime pay or special time pay, or what's going on?
We just love the job.
Just some money. And this is all being recorded and going on LMS, so.
Correct. Whoopsies. Just post-production. That'll fixes everything.
Oh, of course. All right.
In that case,
we
I'll
want
mute my microphone.
You don't have to. It's all good. I don't know how to post-process. So.
That's it.
Just a question. How easy did you find? Did you get the email that this was happening straight away today?
Yes.
Or did you just check LMS?
No, I've been getting emails. I saw it was going to start at 8, but I was kind of, I was watching a show, Mr. Robot, so...
But you did get the email earlier in the
Yeah,
day.
yeah. I saw the email. I went on LMS because I check LMS quite regularly,
Yep.
just to make sure, just to keep ahead and everything. So that's why I saw the new challenge quiz.
Cool. Other than that,
Not challenge quiz, challenge question. Sorry.
the
Which I
only
ended
other
up writing a bash script for that to do because I couldn't be bothered going from A to Z manually. Stop that. I'll just do a bash script.
Oh, to test it.
Yeah.
Yeah, fair enough. Is there any comments you want to make about the assignment, Josh? Any questions that you've had?
No questions that I've had. I think it's, yeah. I don't know if you wanted to go through it.
So I might
Or...
just go through quickly just the first couple of steps to show them what they can start, rather than get into the stuff that they don't know yet.
Good idea.
One thing, however, I will mention one question that I did get this week, and I think Josh or Ash would have the similar problem. When naming your files or executables, really be careful, especially if they're very short. There is a lot of programs on the Unix system, and if you name them as the same thing, you will get a weird response because it's trying to execute that program and not your program. So just be careful with naming your files. Don't call it yes.
Meaningful name.
Pardon?
I think that goes the same way with variables. Don't just have simple single-letter variables. Make something, that makes sense and more legible because it helps themselves and also the people later on down the track when they have to read the code.
Yeah, but so yes is actually a program in Unix that just puts an infinite loop of Y characters. So there's little things like that.
Gonna try that right now. No. Yes. Oh, there it goes. That's
so
brilliant.
So you need to be careful with what you name your assignments and programs. Generally, the best thing to do when naming stuff, make sure that it's longer than 5 characters, because most of the Unix programs are very short. They're usually 2 to 3 characters long. Alright, so in terms of the assignment, we've got our background here. I think it's fairly self-explanatory. Basically, you're trying to measure a circle in 2 different ways. We've got radians and degrees. A full circle is 360 in degrees, and in radians it's 2 pi. To convert from radians to degrees, basically it's radians times 180 divided by pi. Now, with your calculations, this does say degrees here. For your calculations, it doesn't matter. And radians, the other way, it's degrees times pi divided by 180 degrees. Now, we can't put the full pi onto a computer because we don't have unlimited memory. 6 decimal places is enough for a good approximation for your code. Okay, so the first step you definitely can do, and make sure you do this. It needs to print out your name. Do not put John Smith. Do not put your friend's name. You need to change this and put your name here and your student number. And with this, you have enough information from the labs and the lectures to do this part already. You have enough to print this line out. And this week we will do conditional statements, so you'll be able to choose 3 or, oh wait, where am I? Yeah, so you'll be able to choose either 1 or 2 and go to either of these. You'll also do the scanf function this week, so you'll be able to do 3. So by the end of the week, you should be able to get 1, 2, 3, and start doing 4. The looping will be in the week after, and then that's pretty much all you need. So you should be able to get a couple of steps already started and get you off to a good start. And even with that, you can start testing and playing around with it. You should have the lecture notes on conditionals and scanf very shortly too. Or you can look at the lab because the information's there in the lab also. There is some constraints. There is some bonuses. I will put up some marks for that. We're just deciding what value they'll be. There is a hint here. If you don't do the bonus, around 40 to 50 lines of code. If you're going way over that, if it's like 300 lines of code, you're way off. If it's 80, that's fine. If it's a lot less, say 20 lines, you're way off. So it's just a good indication of knowing where you're at. It doesn't mean that your answer's wrong. It may still work, but you may be doing more work than you really have to. And your code may not be very optimized. Don't forget there's a report. We've said 300 plus or minus 150 words. We're not very strict with that. The number of words isn't that important. What we do want to see is keywords and understanding what they are. So make sure you include these keywords or refer to them. They're all part of the code up here. So make sure you understand what they are and in your own words. And don't forget they're going through Turnitin, so they will be checked for plagiarism. If you do plagiarize, if you don't print out your own name, you will get 0 for the whole assignment. Marking guide, go through it. It's pretty thorough, and if you follow it, you can get really good marks. Is there anything you want to add about the assignment, Josh?
I think you've covered most of it. I guess my only advice would be just get started as early as you can. It's often easier just to get it done, get it all over with. At least you'll know from the start what you need to work on, what you don't understand, and then you can ask more questions in labs or in these sessions as well.
One other big thing I will mention about the assignments is that there is no late submissions, and any late submissions will be awarded with 0. Awarded with 0 is kind of weird, but yeah.
Penalized with 0?
Will be allocated a 0.
You'll get negative 100.
Yes. So make sure you submit, and make sure you submit both. But there will not be late submissions for this assignment. The only assignment that will have late submissions is the 3rd one. And if you are sick, you need to tell your lecturer at least 5 days before. Getting a medical certificate the day before is not acceptable. You've had the assignment from week 1. And it's 5%. Anything else? Anything about the labs this week that was issues for anyone?
There was the rounding that was an issue for some people.
Which rounding? Oh.
So the rounding of if you try to do it all in one go.
Yes.
By using the variables beforehand and stuff. Do you want to go through that?
If you give me Let me just see. Give me a minute. We just have a 5-minute break.
Sure.
We'll be back.
As Richard would say, health break.
What?
I said, as would Richard would say, health break.
Yes. Exactly. And I just want to get everything out. Do you want to get it up on your screen, Josh? You can do it on yours.
Yeah, okay, let's do that.
Let me just
You'll have
see.
to.
I just want to make sure that it flicks over to your screen.
Yeah. So, do you want me to write out the code or something? I've got it saved somewhere actually.
Just give me a sec. Yeah. So your screen's up.
Cool.
Except for, I don't know if it's the right screen. Yeah, it's the right screen. Alright, I'll be back in 2
Alright.
minutes.
No worries. I'm just finding where I saved this file.
I'll be back.
No worries.
I'm back.
Hey. So yeah, mine still says 50 newtons when I do the area calculation beforehand.
Yeah, because you're storing it as a double.
But is that what people were doing? No, because area was a float. I'll start as a float.
Yeah, some people are storing it as an int.
I think that was the issue though. Because if they store it as an int, you'll get completely wrong answers. Because it doesn't make sense to store it as an int when you've got to print it out to 3 decimal places.
I did see that. That was the first thing.
Okay, I get 52, I guess. But
Yep. So that was one thing. The second thing is we're doing was import force. So I think it was that they were. So it wasn't in the area one. So if they didn't declare area,
Yeah.
and in the output force calculation, they were doing something else. I'm just trying to remember what they did.
I thought they did this, and that was the issue that people were getting.
Variance.
Hey.
Yeah, that's better.
That's weird. I still get 50 newtons, which is interesting. Maybe it's different through putty or something.
Area out divided by area in.
Yeah.
And then times. Possibly.
That's what I had before.
Yeah, I don't know.
Maybe if we
Maybe input first times area out. So the times is first.
like that.
And then get rid of the brackets.
That 50 newtons.
Okay, I don't know what they were doing.
If we try it on putty, maybe.
No, I don't think that will make a difference.
Don't think. Just a second. Right. So yeah, it's different when you do it on putty for some reason.
Okay.
So yeah, so the issue some people were having this week with the labs was getting these output values slightly different to the input values. Or sorry, to the output values that were expected. So I'll bring up this one here. All right, so the output values were meant to be 50 newtons. Some people were receiving 49 newtons. And
I think I know what it is.
you do?
Yeah, so I think it's GCC not optimized for doubles. So then they're using floating point numbers rather than doubles. So
Okay.
your compiler will be optimized for doubles, whereas GCC on the Unix machine won't be. So it's using floating point numbers.
Makes sense.
Yeah.
So yeah, so if this happened to you for the lab, that would be the reason why. The way around this, you might have seen me wrote on the board, is with a formula you could actually cancel the pi's. So the formula just became the output radius squared over the input radius squared multiplied by the force. And when we change that, so if instead of actually working out what the areas were and calculating it that way, we actually do the whole equation. And we can cancel these pi's out. What we'll actually see is the answers are now what they should be. So as Matt was saying, it's just an issue with the accuracy of how Unix sort of optimizes. So yeah, the way around that and the way whatever you said, I don't know, compiler. Yeah. So yeah, the way around that is simply writing the calculation out instead of working it out beforehand, as we did. So that's if you're having that issue. That's the reason why.
And not only that, just give me a sec. My headphones have been playing up. Can you talk, Josh?
Yeah.
Keep talking.
Yep.
Okay.
Cool. I think I can hear everything now. Not only that, it's also good practice to optimize your code and do your calculations by hand to see where you can make some optimizations and cancel things out. As you can see, we've just reduced one of the operation or two of the operations, and so we've made our code a bit more efficient. The other thing that's good about getting rid of pi is that's an approximation of pi. It's not complete pi. So it's actually making our code more robust and more accurate by cancelling out pi. So wherever you can find optimizations like that, go ahead and do it. It's good practice. All right. So I think we started at 10:20. So I think we're pretty much done unless there's any other questions.
No, I'm good.
You're all good?
Yep.
All right.
Yeah, I didn't
Sure,
have any
awesome.
problems with the apart from I spoke to you in regards to the force calculator. Oh, that.
Which one?
I think I
The
spoke to you. Yeah, you were told me what the
HSL?
problem was. No, not the HSL. Yeah, I got that one working.
Which
But
one?
I'm talking about the one that you just talked about just then.
Okay.
The
Yep.
force calculator. No, sorry.
Yeah. It's a hydraulic.
That one. Hydraulics. That's it. But anyway. But all my answers, all the results that I had were pretty much right. I just had a problem with one thing which I ended up speaking to you about, so.
Yeah. Cool. All right.
Cool.
Could, just a question before you go. Can you see the screen all of that clearly?
Well, I've got it slightly minimized because I'm doing other stuff. Well, yes, on my screen, perfectly fine.
Yep.
Cool.
Some people might have to watch it in full screen.
Yep. All right.
Yeah.
Cool. All right. Thanks for coming.
Awesome.
All right. Thanks for having this.
Let's
Have a good weekend.